we're going to begin to start classifying chemical reactions based on some basic structures of how things play out when atoms are rearranged. And so the first reaction type we're going to look at is called a synthesis reaction or a combination reaction. So a synthesis reaction happens when two things combine into one thing. Now these can either be two elements forming a compound, or they could say be an element in a compound forming a more complex compound. The simplest version of this would be something like hydrogen gas reacting with oxygen gas to produce water. So let's talk about this reaction. Before we do that, go ahead and jot it down as an example of a synthesis reaction and see if you can balance it. Go ahead and pause the video and do that. Okay, so we have two hydrogens on the left and two hydrogens on the right, so that's good. Two oxygens on the left, but only one oxygen on the right, so we're going to have to double that oxygen. That throws off the hydrogens just a little bit. We now have 4 on the right, so we need 2 H2. So 2, 1, 2 would be the balance for that equation. This particular reaction, so there's about 20% oxygen in the atmosphere and a fair bit of hydrogen. And though this reaction will happen, it does not happen under normal temperatures and pressures. It actually takes quite a bit of input of energy. Or I should say it will happen at normal pressures but not temperatures. It takes quite a bit of energy to get this reaction going, and then once it gets going, it's actually a fairly violent reaction. There's a pretty big fireball explosion when hydrogen reacts with oxygen. It's worth playing around on the YouTubes a little bit and trying to check out hydrogen-oxygen reactions, because there's a lot of creative ways of doing this particular reaction. But that's a combination reaction, two things combine together to form a third thing. So if you have one product, then it's a good bet that you have a synthesis reaction. The reverse of that is the decomposition reaction. Decomposition reactions happens when one thing breaks down into two smaller things. So an example of that would be the decomposition of potassium chlorate, KClO3, into potassium chloride and oxygen gas. Essentially, you're pulling that oxygen gas out. Again, jot this equation down as an example of a decomposition reaction. Go ahead and pause the video, see if you can balance it on your own. So one of the patterns you'll start to see with balancing chemical equations is we look at the oxygens here on the left and the right. We have a 2 and we have a 3. Again, that means to look for the least common multiple, which is going to be 6. So we're going to have to put the 3 and the 2 on the coefficients there in order to get 6 oxygens on both sides. That means I now have 2 potassiums and 2 chlorines on the left, so I'll need a coefficient of 2 there. So the balance here is going to be 2, 2, 3. So that's a decomposition reaction. If you have one reactant, you probably have a decomposition reaction. The third reaction type we're going to talk about in this video is a single replacement reaction, and we're going to go into this one in a little more depth. So general structure here is A plus BX goes to AX plus B. Essentially, the A is replacing the B in this process. So if BX is an ionic compound, B is a cation, and so A has to be able to form a cation if it's going to replace B. If A were to form an anion, then it would more likely replace X than it would replace B. And so we'll start with a couple of examples. Aluminum and a solution of iron 2 sulfate, and copper 2 nitrate, and nickel. So what I want you to do is write out both sets of reactants with a arrow next to them. So see if you can write those chemical formulas out, and we'll talk about what the products are going to be here in just a second. So go ahead and pause the video and do that. Okay, so if you did the first one, you should have aluminum. It's a metal, so it's going to be solid. And then we have a solution of iron 2 sulfate. Iron is a 2+, sulfate is a 2-, so you should have FeSO4. And in a single replacement reaction, the aluminum is going to replace the iron, so it has to replace whatever forms the same charge that it can. Iron is going to get kicked out. It's going to form a solid, so iron is going to precipitate out of the solution. So you have a solution of iron sulfate. Whenever you have a solid forming from a solution, that is a precipitate. And then the aluminum is going to form a compound with aluminum sulfate. And so you have to balance that chemical formula. Sulfate's a 2 minus, aluminum's a 3 plus. That's why we're at Al2SO4 3. In order to balance that, you're going to need 2 aluminums on the left, cancel out the 2 on the right. We're going to need 3 sulfates on the left, cancel the 3 sulfates on the right. And sure enough, when you do that, by the time you get to the iron, it's already going to be balanced. You just need to add that 3 on the iron. Again, you can, if you have polyatomic ions on both sides, rather than balancing sulfur and oxygen, you can balance number of polyatomic ions. So with that example of a single replacement reaction, see if you can, if you've already written the reactant, see if you can complete the reaction for the second reaction here and go ahead and balance it. Okay, hopefully you paused the video and did that. So in this case we have nickel as the solid reacting with copper nitrate, copper 2 plus, so that's why we need 2 nitrates each at 1 minus. So nickel can form a 2 plus or a 3 plus, and so for the time being we're going to take the following assumption. If a thing can form the same charge that it's replacing, it will. So given the choice between a copper 2 plus and a 3 plus, for right now we're going to go ahead and take that 2 plus because the copper, it's replacing the copper, which is a 2 plus. And so because it replaced it with a 2 plus, everything is already going to be balanced. We have 1 nickel on each side, we have 1 copper on each side, and 2 nitrates on each side. Let's continue to explore the single replacement reaction by looking at this one. So again, see if you can pause the video and write a complete balanced equation, predict the products here, and then balance the equation given sodium bromide in aqueous solution reacting with chlorine gas. All right, hopefully you paused the video. So here we are. Sodium bromide is going to react with chlorine. We want to think about in a single replacement reaction what's going to happen here. Chlorine is forms an anion. So in order to replace something in sodium bromide, it has to replace the thing that is the anion, in this case bromine. The other thing to remember about this reaction is diatomics. Both chlorine and bromine, when they're by themselves, are diatomics, and that has an impact on your balancing. So there's a single replacement reaction in which a nonmetal replaces the anion out of an ionic compound. Let's keep going. So here we have zinc chloride and 10. So see if you can write out reactants for that equation and see if you can predict some products. And so if you went ahead and did that, pause the video, what you're going to find now is I tricked you just a little bit because this one is not going to have a reaction. The tin is not going to replace the zinc. How do we know that? So if you have your data packets, if you have them printed, you should take those out. If you don't, you should look them up. And in your data packet, we have a thing called the activity series of metals. Increasing activity or reactivity as you go up. They're the things most likely to be in a compound because they've either gained or lost electrons to do that. In this case, since it's the activity series of metals, they will have all lost electrons. And so what we see here in that last reaction, 10 was trying to replace zinc. And so zinc is right here on the activity series in the middle, and 10 is a little bit further down. The only thing that 10 can replace are the elements below it on the activity series. Since zinc is above it, it will not replace zinc out of a compound, and that's why we have no reaction. So anytime you have a single replacement reaction, you have to check the activity series of metals. So that's why with zinc chloride and 10, we get no reaction. Let's take a look at hydrofluoric acid and chlorine gas. So that's going to be HF and Cl2. So if you think about what the chlorine would have to replace, the hydrogen here is H plus or a cation, and the fluorine is F minus, so the chlorine would have to replace fluorine. But once again, we get no reaction. Why do we get no reaction? Well, The halogens form their own activity series. And as you go up the periodic table, you get more reactive and more likely to be in compounds. Chlorine cannot replace a fluorine because it's above it on the activity series. Chlorine could, as we saw in a previous reaction, replace a bromine. It could also replace iodine. There we also have astatine and the TS down there. Those are less common elements. When dealing with halogens, we're usually dealing with the first four in chemical reactions. So that is our first three types of reactions.